And it can be loaded from the content distribution network, which is basically you don't need the browser. You don't need to depend on the browser. The JavaScripts can be already loaded from the CDNs, so it will load the page pretty faster. So the advantages of it are it's appealing to use. The users will find it more interactive. It has a large library, a large open source community. It creates effects, animations, and it's very easy to use. It has AJAX support as well as CSS support. The uses of jQuery in wiki pages. It can be used for registering as well as login, drop-down menus, slideshows of pictures in the featured article and the news of the day section in the main page of the Wikipedia site. Ticker in the news section, which I'll be demonstrating in the later on. And the static table of contents sliding down, where you don't have to scroll up to see the table of contents every time. So this is one implementation. It's just a screenshot where the contents table is actually, nowadays you'll find it, the content table right below the introductory paragraph. And it's just a random article I picked out. So the contents table will actually be hidden inside, and when you click on the gray rectangle box, when you click on it, it will come out. And it will scroll down as you move down. So it will actually be helpful in pages which are slightly bigger, like 1.5 MB or more, which take more time to load. Second implementation is in the today's featured article, as I just mentioned. Different photographs for the today, like that day it was Statue of Liberty, so different photographs related to that. And in the news, it would be a ticker, which the news is sliding up, which I'll show you after the presentation. The next thing is AJAX. AJAX allows the web pages to be updated at regular intervals of time in parts. So in a nutshell, the web page doesn't load on its own, part of web pages load. So this has been effectively utilized by web giants like Google in the Google Maps. Suppose if I search for a map, search for a city in the Google map, you will notice that the URL doesn't change. So if I type New Delhi, it has already preloaded, so the URL won't change. The page won't know what thing I'm searching for in the map. Similarly, if I search for New York, the URL doesn't change, or my college. So what is AJAX? It consists of three parts: JavaScript, asynchronously calling to the server, and an XML file stored on in the browser's cache. JavaScript is used to implement the functions which are stored in the CDNs again. Asynchronous call to the server, it is sent through XML HTTP request, which is a function, and it is sent to the web server at period of time. And XML, which stores the data at regular intervals in the browser's cache. So the main idea is less is more, where actually in bigger web pages, this can be implemented successfully. So the advantages are simple. AJAX can be used to develop web applications that can update the page continuously without refreshing it. So it can be updated at regular intervals of time. The whole web page would be more compact. Pages like Telangana or Greek crisis, these are pretty big. So one won't have to scroll down through large paragraphs. Bandwidth usage, it will use less bandwidth. Traffic to and from the server is reduced. For technical guys, it's actually a brilliant idea. Form validation, and it's simple for the user. Disadvantages are, since the URL doesn't change, as I showed you, it might be difficult for you to bookmark or return to the previous state as you were before. So users of AJAX in Wiki are registering or logging into the Wiki database directly without changing the page you are on. Loading each topic from the table of contents simultaneously as and when the user selects it. Table of contents sliding down, again it uses jQuery, CSS, and AJAX. Live search for wiki content. This is a new concept, but unfortunately I don't have net right now, so I can't show you. Editing the wiki content in a pop-out dialog box dynamically Now when you have to edit a wiki content, it takes you to a new wiki page where you actually have to implement it. Now what Ajax can do is it will allow you to edit the wiki database dynamically on the same page where you are on. So these are a pretty cool, simple screenshots where right now in a normal wiki page, login and create account comes at the right corner. What I have suggested is simple use of jQuery and Ajax. A simple layout like this would slide down, and here the user can actually enter his details, username and password dynamically, and he will stay on the same page without going to a newer page. Same ways, this is the other implementation of Ajax where it's the live search, where it stores a string in a two-dimensional array and it searches letter by letter. So there are actually 10 tabs opened up, and as soon as you don't even need to enter it. You just type it, and the first one will automatically appear in the lower half of the screen. That's it. And the implementations I want to show you. The first one is this thing I'm talking about. Right now, the content box comes below the introductory paragraph. What I've implemented is the contents of the content box will slide down as and when I go up and down the page. So it is actually helpful in the bigger pages, which are more than 1.5 MB, which take a lot of time, especially for me when I'm in college. It takes a lot of time to load. Second implementation is, it's because of the projector, I'm not able to show you completely, but in the news is actually going as a Tigger. Anyways, and the jQuery slideshow, which I was talking about, where actually in the today's featured article, the different photographs of like that day it was Statue of Liberty. So Statue of Liberty, different photographs of Statue of Liberty can appear. This is actually Tigger. And the third thing is this. What I've implemented is login register, where instead of the earlier thing, you can actually slide it down, enter your credentials here, or either your register here, and then close it down, and still you will remain on the same page rather than going to a new page. And finally, Wiki Live Search is not working because there's no internet. So thank you. That's the presentation. And thank you. Dimensional array. So in the first dimension of the array, it stores the letter by letter, and the second dimension, in the second array, it stores the whole word. So as and when you type FOOTBALL, it searches for F, then FO, then FO, then FOO, and it stores the whole string in the next array. So as and when you type in, it actually stores and sends the XML request to the server, and it will show you the result as and when you type it. I hope I answered your question. This is not implemented in Wikipedia as of now. Any other questions? Thank you. Thank you.
Right. Hello, everyone. I'm the next speaker. My name is Devayan. My laptop's a little slow, so you will have to excuse it while it boots up. But that doesn't stop me from starting the presentation. If you look at your schedules, we've got some very interesting talks now, starting with mine, self-promotion, and then two other talks. I think Eric's ending the last talk and the most interesting. We are going to be talking about semantic data and the Wikidata project. I want to talk to you before all that. I want to talk to you about this site, which I like a lot. You call it a site, call it a web application. It's a big W, and it solves a lot of my problems. I use it almost every single day. I use it for finding out stuff like what's Sonia Gandhi's age, what's Shah Rukh Khan's age, what is Sonia Gandhi's age minus Shah Rukh Khan's age, which is 18 years and 43 days, I guess. Of course, I don't see why you would be interested, but I have questions like that in my mind. And that site, which starts with a W, is unfortunately not Wikipedia. It's wolframalpha.com. And has anybody gone to that website by any chance? Oh, okay, good. We see a lot of hands. I'm feeling less nervous. Great. So, what does wolframalpha.com do? Let me just, give me 10 seconds. I'll just switch it on and then tell you something interesting. And while I say this, all decent editors of Wikipedia should be quite upset because Wolfram Alpha is proprietary. The information you find that is not licensed freely. So you get into a lot of trouble if you work with that. But still, it's something which I use every day, and I see a lot of iPhone users in the audience, Apple fanatics. You will be very happy that the iPhone 4S uses Siri, which basically you can ask what's the weather here in Mumbai, and it can answer. It also answers questions using Wolfram Alpha. So what are these applications are computational engines, and what they can do is they can answer your questions based on semantic data which is available on the internet. Also, I suppose my slide is not going to be of much interest because the light is falling on the screen. I'll blame the light, not my sloppy slides. So when you ask Wolfram Alpha, what's Shah Rukh Khan's age? How come Wolfram Alpha knows Shah Rukh Khan's age? I mean, Shah Rukh Khan is an Indian celebrity. Okay, maybe he's known across in the South Asian community, but how does that information get in? Well, funnily enough, it's from the information usually comes from Wikipedia. In fact, those people who are involved in semantic data extraction, they would tell you that most of these websites, they look at algorithms to mine data from usually Wikipedia. But mining this data is usually fraught with problems because the data in Wikipedia is usually written in English. It's meant for human consumption. It is not meant for programs to read and extract data. So although that it's possible to do it, it's not a 100% reliable solution. So one of the solutions which we could do to solve this is what if we had a wiki where we could store semantic information. I was working with a software like this. It's called the Semantic Media Wiki, which is what my talk is briefly going to be about. Now, Semantic Media Wiki is an extension for the Media Wiki software. It's developed by a lot of guys in the European Union. A lot of people use MediaWiki privately. They install it on their own servers and maintain wikis, like Unencyclopedia, I guess, which we spoke of a little earlier. So Semantic MediaWiki is an extension you could install along with MediaWiki on your server, and it would allow you to have semantic data stored in this wiki. So this is one of the solutions in which you could solve this problem. This summer, in the Google Summer of Code, I was part of the Google Summer of Code, and I helped do some work with some excellent help from Sumana, whom you met just now. And it was a really fun project. Here I would like to make a minor interruption and make a big sales pitch. There are a lot of people in the audience who are just joining college or who are still studying. Well, I would really urge you to look at the Google Summer of Project because here you get a lot of money, you get to contribute, and I'm sure if you think of a good proposal, there's no reason why they would not, the Wikimedia Foundation would not accept it. They pay you a lot of cool bucks, and it's a good status symbol also, I guess. Okay. So there are other databases where semantic information is kept. The next talk is on DBpedia, so I'm not going to talk about this much, and plus we are running short of time. Yeah, so forgive my unstructured talk, but what is the advantage that why am I talking gibberish about semantic web and semantic information, and why should we have semantic information in Wiki? Because then what you can do is that once you have a data store of semantic information, once you are able to make programs understand what is it that this page contains, that this page contains Sonia Gandhi's age, then you can reason over it. Then you can have programs like the Apple Siri who can reason over it and calculate stuff. So then you can ask a question like, what is Sonia Gandhi's age today? Or when is her birthday? Or set a reminder on my phone when Sonia Gandhi's birthday comes up. So you can do a lot of things like that, and these things could be automated. You don't have to go to Wikipedia, look up the page, find out the information, then go to your phone, then do this. So we are on the path. A lot of progress is being made, and as you will see from the next presentation, we'll talk. I think we'll speak a bit about RDF. So that goes over to the technical side. But I'm trying to concentrate on what it means to you as users, what advantage you will get. Okay, so that's what I was talking about. Wikimedia contains Wikipedia contains a lot of information, and semantic web allows you to allows the programs to reason over it. So it's a marriage made in heaven, provided we could have semantic information available from a wiki. And that is where the Semantic Media Wiki project comes in. I would strongly urge you to Google it up, because we are on short on time, and it's an extremely interesting project, and they're looking for contributors. So if you have any interest in this field, I would strongly urge that you get in touch with the developers there. Since we are short on time, I'll not go into the syntax, but I would just say that the main disadvantage here is the same perhaps that the Media Wiki software itself suffers from, that you are putting in text in a specific style. It has its own language, as you would say. A visual editor here would be a godsend. Okay, so I was part of Google Summer of Code, and I was working with Marcus, Jorin, Yaron, and they were extremely helpful, along with Sumana, whom you met. And there are some excellent use cases of this, including databases on finding stuff on gardens, websites, and a semantic database on webcomics. But we can, of course, you don't need to bring your ideas to Wikipedia. You can obviously install this on your own servers, and you could have a database of ghazals, which could be searched for through tone or ideas or singers, maybe about Indian recipes. And then finally, an idea which I thought about is that a simple way to fight corruption, because corruption is in the news lately. What you can do is think about some public service which you're not getting in your area where you live, and you could put it up on a wiki, and you can mark it on a map, because Semantic Media Wiki also, the extension also supports maps. And if everyone puts in the status of whether they are getting local supplies in their particular place or location, an administrator or even a general layman can easily go to the net and find out, okay, is everyone getting, is water supply available in ample amounts all over Mumbai, all over India? If you've got contributors all over India, then it can definitely happen. If you've got more ideas, or if you want to know more about my idea, I'm pretty sure we can talk offline. So Semantic Media Wiki is pretty easy to use. Hire a server. If you don't want to configure your own server, it's available on Wiki and Referata. Yeah, so we'll not talk about Wikidata, because Eric is going to talk about it, and there's a lot of interesting stuff about this. And with that, thank you. Do we have any questions? Okay, thank you so much.
Few questions. I hope you can read them. The first question is, which are the companies owned by Sony and located in India? So the answer that I'm expecting is Sony Pictures Imageworks. But right now I don't have internet, so suppose you just go back and try to query this on Wikipedia. Companies owned by Sony and located in India. So you will not get this result which you are expecting. You will not get Sony Pictures Imageworks. So, and similarly, questions like which universities in India located in Mumbai were established before 1975. You need the exact list of universities. That's not available using Wikipedia search. So, DBpedia is a tool that can facilitate this querying. It is done by University of Leipzig in Germany, and also with the Free University of Berlin, along with the collaboration of OpenLink software. So what happens is that it is merely a tool which creates a database from the Wikipedia dump and prepares that database in such a way that it can be queried by inputting a query in a particular format. So I'll talk about that in detail. So let's have a look at how information is organized in Wikipedia. So the most important part of a page in Wikipedia is the info box. For example, this is a page of Mumbai. So you can see that all the important things like country, state, district, all these things are present in the info boxes on the right-hand side. Also, we have some other information like the geo coordinates, title, this version, the different versions, language versions, which category it is. So if you can have a look at this, actually, see the subject is Mumbai. The Mumbai has property country whose value is India. Similarly, Mumbai has a property state whose value is Maharashtra. So what we are trying to do is we have to extract all this information from Wikipedia and represent it in a format that can be queried. So DBpedia has an extraction framework which is quite complex, which what it basically does, it scans all these pages from Wikipedia and converts it into the format that I told. So that format, representation of that such format is called as RDF. RDF stands for Resource Description Framework. I'll talk about that later on. So you all know that Wikipedia contains wiki markup, right? So for example, the info box. So info box contains like the code, something like this. So this is equal to Bombay value, something like that. So what the tool does it looks at these kind of wiki markup code and converts into RDF representation. I'll talk about RDF later on. So this is what it looks like. So wiki markup into RDF. That is what basically the extraction framework does. So as I told you, the one on the right-hand side is an RDF representation. So what is RDF? RDF stands for Resource Description Framework. So it can be called as a building block of semantic web because RDF formats can be easily read by machines and then it can be used to run processes and operations. So as I told you, DBpedia uses RDF for representing the extracted information. So RDF, typically, there are many ways of representing statements in RDF, but a typical representation consists of three parts: a subject, predicate, and an object. So let me go back a few slides. Let's take this example. Here, the subject is Mumbai. Predicate is a property. So for example, you can take any property, time zone, area. So this is a property, so predicate. And the value of that predicate is the object. So in this case, Maharashtra is a object, state is a predicate, and Mumbai is the subject. So you see that it's a combination of three values, right? Subject, predicate, and object. So the combination of these three things form a statement, RDF statement. So let me just put it all together. I've taken this example. Mumbai is the birthplace of Rajiv Gandhi. So Rajiv Gandhi is the subject here. Birthplace is the property that we are trying to define, and the value is Mumbai. So just have a look at this side, subject, predicate, and object. So we can't directly give Rajiv Gandhi because it's just a string value, right? So for DBpedia to understand, we have to have a page which describes what is Rajiv Gandhi. Is it an entity, or is it a string, or is it a date time? What kind of data type it is? So what happens is that in this page, right now I don't have the internet to show you, dbpedia.org/resource. So you see that subjects and objects are resources, right? And as I told you, predicate is a property. So on this page, all the actual description of these subjects, predicate, and objects is there. So the RDF statement consists of 1, 2, 3, three things followed by a dot. So this is a statement. So this, what you see is a URL-like thing, which is called as URI, Uniform Resource Identifier. So three sets of Uniform Resource Identifiers forms a RDF statement. And so while you use this, because every time you don't have to repeat the whole URI, because as you can see, Rajiv Gandhi and Mumbai, till here it's the same, right? So /Mumbai and / Rajiv Gandhi, that's what it's changing. So what you can do is that you can remove the first part of the URI by a prefix so that you can shorten it so that it is convenient for your use, and the prefix can be expanded by the computer or the software tool that is using, and it can be expanded like this. So let me replace the first, in these three statements, let me replace the first and the third statements by dbr and the middle statement by dbp. It's like a shortcut. So first you have to define at the top what are the shortcuts they're using. So DBR stands for this thing, DBP stands for this thing. So now the previous 3-line statement can be represented in a single line using DBR, Rajiv Gandhi, so and so. So it can be read by Rajiv Gandhi has a property birthplace whose value is Mumbai. So it's another way of representing the same RDF statement. So why are we using RDF to represent it? Why don't we use it as like a simple SQL database or something like that? So the thing is that multiple statements can be linked, because I told you that RDF statements consist of 3 things, right? So suppose take the example of Mumbai. Mumbai can have a lot of properties like population, city, code, pin code, whatever it is. So when you try to model this together, you can form a map kind of thing that can be interlinked. So when you want to run complex queries, you want to go property of a property of a property. So that is possible when you use RDF. For example, you can see this Mumbai has a lot of properties like country, postal code, synonyms, birthplace. So if you want to go Mumbai, birthplace, Rajiv Gandhi, citizenship, this is just a small example. In the real world, there is it can go really complex. So how do you query this RDF graph? So I told you that the whole thing forms like a graph. So how do you query this? That's what we want, right? We want to find answers to queries such as what is the capital of so-and-so state, something like that, right? So in order to query this, we make use of a language called as Sparkle. Sparkle is similar to SQL. So Sparkle stands for Simple Protocol and RDF Query Languages. So it is really simple. It is, SQL has select and where, right? So a simple format of Sparkle is select variables, where, conditions. So variables in Sparkle is denoted by question mark. We don't have that in SQL, right? And conditions. So in the conditions, you give what condition you want. So all the cities having capital X, okay? So form a RDF statement of that and put it in the where condition. So I want to find the capital of India. So what you do is, see, the prefix part is optional. If you can expand it and write, you can do that. So you want to find the capital, right? So name a variable, anything, capital or X or Y. So question mark capital is a variable whose value you need to find. Okay, so what is the condition? So that second last line is the RDF statement, the condition, right? So DBR India. So India is already a resource that is existing. DBR stands for the whole thing, right? So India has property capital whose value is unknown, that we need to find, whose value is a variable. So if you execute this query, you get the value of capital, and what we are selecting is a capital, right? So the capital, the value, New Delhi will be returned. So right now I don't have the connection to execute this and show you. So this is a simple example. Is there any doubt so far? Yeah, please. Yeah, I'll show you where you will run. Actually, you need something. Either you can set it up in your local system. For that, you need something called as OpenLink Virtuoso. For example, if to run SQL queries, you use a Microsoft server, something like that, right? So for running Sparkle queries, you need to have a different kind of database, RDF database, and use OpenLink Virtuoso. But since this tool is already made to facilitate such querying, they have an online access system. So it's a web-based system, a web-based access system. So you just have to paste your queries, and you will get the result as an output. Okay? So I'll proceed. So the answer to your question, how do you query DBpedia? So as I told you that DBpedia extracts information from Wikipedia, right? So right now there are more than 1 billion pieces of RDF statements that has been extracted from the info boxes, geo-coordinates, categories, and so on. So so you can actually make use of this to query the entire knowledge of Wikipedia using this tool. So how you can access this is that the first thing I told you that there's a web-based interface. This is the URL for that, dbpedia.org.snorkel. Okay, so if you go there, there'll be a text field where you can paste your queries, and it will fetch you the results. Or else you can, there is another similar interface which is not a querying based of thing. It's already a map kind of thing is there. I'll just see this thing. On the right hand side, what you see is the link data interface, the second kind of interface. So it is like a kind of visual thing. So if you want to know more about country, or suppose you click on DBpedia India, it goes to a page which shows what are the properties of India and what are the values it has. So this is like you can click and you can browse the whole thing, link data thing. Or you can, as I told you can download the data set. It's a huge thing. And you can set up your local system if you have all the OpenLink virtuoso set up. So right now I don't have the internet to show you these things. As I showed you in the first slides, these are the queries. Like universities in India located in Mumbai. You can add on conditions, whatever you want. So just focus on the later part because the first parts are the prefixes. So what do you want to find? You want to find institutes. So make a variable of that, question mark institutes. It can be anything, X, Y, anything. And you give the conditions inside the where clause, right? So first of all, you have to define what is an institute. So because the DBpedia tool is not intelligent, so it needs to know what you're looking for. Is it some string or what kind of data type it is? So where is it? Yeah. So this is the statement that tells DBpedia institute has a property type, which is a university. So it is a type of university. Okay. Now you are filtering down on all. Suppose if you run just this query, you'll get all the university list extracted from Wikipedia. So now we are filtering on that. The university is located in a city called as Mumbai. It has a country, India. You can remove that if you want. So when you run these queries, you get all the universities in Mumbai, and you need to know which were established before 1975, right? So you need another variable, institutes established date. So far this date doesn't have any value, right? So you filter date less than 1975. So this is how the query gets complex and you get refined results. So did you understand this? Like, is it okay? Yeah. So another example, list of Hindi movies having runtime greater than 3 hours and starring Anil Kapoor. So you want to find movie and runtime. So only if you need the list of movies, select question mark movie. And inside the where condition, first of all, okay, what are you looking for? Movie. Movie is a type of film. Okay. So the next condition is that it should have a language which is defined by standard Hindi, and then it should have a actor Anil Kapoor, and you need to filter on the runtime, right? So you need to define that variable runtime, question mark runtime. What is the condition? Runtime greater than 10,800 seconds. It accepts data in seconds. So when you execute this query, you'll get the list of movies having this condition. This is another example. See, so far you got the results in English, right? So the Wikipedia has information in lots of languages. So suppose in this example, you need information about Germany in German language. So what it does so you are trying to pull out data from the abstract section. So suppose you go to a wiki page, there is a section at the top which is the abstract, right? It gives a brief introduction. So you need to know data about in Germany. So select abstract and DBR Germany. So Germany is a resource which is already defined. So there is no need for defining like Germany RDF type country. Even if you don't give that, it will give the result because DBR Germany is already defined. And it has a property abstract whose value is question mark abstract. We don't know, we need to find that. And what is the condition? We need the language to be matched as German. So we give it as DE. If you don't give this, the results will be in English. So what are the use cases of DBpedia? The most obvious use is to improve your Wikipedia search. So if you need answers to specific queries, you can use this tool to get the results. The only thing is that you need to have a small understanding of the Sparkle query. So once you start using it, try experimenting it, you can get the hang of it. And the second use is DBpedia page for your web pages. Suppose you are writing a blog or a web page about some cities in India. So you need to pull some information, like you need to order the cities based on the population or something like that. So you need a table for your web page. So what you do is you get this, see this is a Sparkle statement, right? So you can use, like we had a previous session on jQuery, right? So you can use jQuery to execute Sparkle queries. What you do is you use something called as curl. And then using jQuery, you can link it to the UI and to the HTML page or whatever it is. So you can put that on a web page. So the third thing is mobile and geographic applications. So I told you that Wikipedia pages also have geographic coordinates, right? So if you are, suppose somebody, see already an application is made, DBpedia mobile. So what it does is that suppose you have this application on your phone and you get your GPS locations. So it tries to identify what are the entities around you, and then it tags with it with semantic content. So suppose you are here in University of Mumbai, it will be highlighted. So if you click on University of Mumbai, you know what are the things, the properties, nearby areas and things like that. So I think if you are able to get the slides, you can just click on the links and get more information about it. And document enhancements. So these are two applications which are already made using DBpedia. So Spotlight is used for annotation. So simply if you want to annotate a document, suppose I tell you that Mumbai is the capital of Maharashtra or something like that. So you need to insert more data. Semantically, you need to enhance the document. So what this tool does is that it creates hyperlinks for Mumbai, Maharashtra, so that when the user clicks on Maharashtra, it takes to that page of Maharashtra, and you can see more details about Maharashtra and so on. And the other tool, Semanda, is used for blogging. What again it does is that it's an application you can give you can just paste the text, and it tries to find a lot of information related to this, pictures, music videos, videos from YouTube, and then so you're just giving the text to the tool, right? And then it enriches your whole blog it finds the related pictures and videos and so on. So you just can blog instantly with that without going to search for multimedia things. And support Wikipedia authors. In this case, like I give you an example how you can query about different languages, right? So the most important thing is that the consistency of data across languages. So even if you run the same query in English or in different languages, the answer that you are getting should be consistent, right? The answer shouldn't be different. So Wikipedia authors can use this tool to validate the data existing in pages in different languages. This is an example. And other applications, relationship finder. So this thing also requires internet to demonstrate. For example, this tool asks for two entities. Suppose I give Albert Einstein and India and execute that. It tries to find what are the relationships between these two entities. So it can be direct or indirect. So Albert Einstein might have a mentor who had a mentor who lived in India. It tries to find the connection between these two entities using the DBpedia tool. So these are 6 examples of how DBpedia can be used and is used. So what are the few problems associated with DBpedia? Because the information in Wikipedia keeps on changing, right? So as I told you, the DBpedia extraction framework it is used to extract information from the info boxes and so on. So if information changes in Wikipedia, it needs to be reflected in DBpedia. So there is a lag between the refresh. So the problem is it is not synchronized. If some data is updated in Wikipedia, it is updated only when the DBpedia database is refreshed next time, right? So, but right now they have started to work on a new project that is live stats. So what happens is that they are trying to improve this by instantly checking and updating the entities. So you can see some examples. See number of instances updated within the last minutes, 83, last 5 minutes, and so on. These are the statistics related to this project, and which is the 20 most recently updated entities, link for DBpedia and Wikipedia. So you can see that the updates in Wikipedia should be reflected in DBpedia. And data cleansing is required because, for example, see here, movie runtime, right? So movie has a property runtime. So people may use different names for the same thing, right? So runtime may be running time, runtime. So there is a inconsistency because there is no standard for all these. So the properties like birthplace and place of birth. So you need to find all those people who are born in Mumbai. So should we give place of birth or birthplace as a property? So in order to get the full list, maybe you'll have to give both these queries. So that is a problem DBpedia has. So data cleansing is required to merge these things. So I think that's it. If you have any questions, I can try to answer it. Yeah. Can you just repeat it?
You gave the example of the query to find the relationship between Einstein and Mumbai.
Yeah.
Do you happen to know what the runtime is? How efficient is that in terms of the total number of statements in the database?
Okay, you need to know the efficiency of that, right?
Yeah.
See, actually, it is a third-party application which is implemented using DBpedia. So I really don't know about that. But like when I tried, I just inputted these entities, and within 1 minute, it's like a real-time thing. So the relationships keeps on updating, and it forms a web kind of thing. So the web grows. So as and when the new relationships are established, the whole thing grows. So you just can get the slides and you can try it for yourself. But actually, this is not a part of DBpedia. This is an application which is built on top of DBpedia.
So I'm going to show a bunch of stuff. So if you can't see this tiny screen all the way from the back there, and you actually want to get some value out of this, then I encourage you to actually come up in front. I can wait. Come on, pack up your stuff, move up front, so you can actually see some things that I'm going to show. Thank you. So we talked a little bit, and is the screen okay? Can you see okay? Okay. So if you can't see or you can't hear, please let me know. So I'm going to expand a little bit on the concepts of the previous sessions, and I'm going to also go a little bit back to the basics of why we're thinking about structure in wikis and what it means to think about structure in wikis. So we know that in the context of Wikipedia, data is really treated like text. And that's pretty painful for a lot of advanced applications and uses that you might have for that data. So when we think about data in Wikipedia, we encounter things like citations. We encounter all these key value pairs like population equals something, or the gross domestic product of a country is this or that. So we have all these data points that are associated with articles, but we also have these manually maintained lists. And there are other examples of data, like the links between articles, also the articles in different languages. And so if you have a very rich Wikipedia article, like this article about the moon Europa, then underlying this, there's a lot of data in that article. But the way that data is represented in Wikipedia is plain text. So you can't see this really well, but you basically just have a bunch of markup in the page. And it doesn't do very much with that data when you save the page. It extracts some amount of information that it needs in order to perform certain operations efficiently. So it tracks what page links to what other page, but it doesn't do very much beyond that. So there are new efforts like DBpedia, which were designed to work around that to some extent by extracting some of this data. But going back to the roots, so this is just an install of MediaWiki running on my laptop. So I'm making this deliberately very large so you can see it. And if I'm editing this page here and putting some stuff in it, and saving it, that's really all the wiki knows how to do well, is how to save text, how to modify text. Now, over time, people have started doing other things. So let's say we had a page about the WikiConference India. And there is some information about the WikiConference India, the name of the conference, the date when it happens, the location where it happens, the organizer of the conference. And so this is managed in Wikipedia typically by means of these things called templates. So who in this room has encountered this markup before and who knows how to edit templates? So I would say about 30% in the room know how to edit templates, or at least are paying attention to what I'm saying. So if you are looking at this markup here, what's going on here is that I'm describing the WikiConference India with certain properties, the name of the conference, the date, etc. But what's actually happening is that it pulls from a separate page, and that page is called template:event, and that page is used to format the event information. So if you look at the source of this page, then you see some slightly more complicated markup. So a little bit of HTML, a table, but the important bit here is that you have these bits here, organizer, location, date, name, that are substituted into the page where I parameterize them from another page. So templates are a way to reuse some amount of formatting from page to page. So I substitute certain values into this format so that I can reuse them. So if I have a different page about an event, so this one is about the WikiConference India, let's say I had a page about Wikimania, I have a different set of information about that event, and so I call the same template, event template, with a few different parameters, but it formats it in exactly the same way. So this is a feature of MediaWiki, our software, and it's a feature that's used extensively in Wikipedia. So understanding how templates works is pretty important if you want to do anything with data in Wikipedia today. Data in Wikipedia typically resides in some form of template or other. So when you're dealing with citations in the English Wikipedia, for example, they are formatted using templates. When you're dealing with the information boxes in articles about countries, they are formatted using templates. So most of the data that you find is in this form. But it doesn't actually store it in any structured form in the MySQL database that sits behind Wikipedia. It doesn't do anything very smart with it. So folks like the DBpedia people have taken it upon themselves to say, okay, how can we extract that data meaningfully and make it available to other people to build applications with it and do smart things with it? But then other folks like the Semantic Media Wiki people have said, well, can't we make the wiki itself smarter in the way that it deals with data? So Semantic Media Wiki, as was previously mentioned, is an extension which adds a bunch of cool data-related functionality. So let me show you what that looks like. So you can see here that the page that I'm loading here looks exactly the same as the one that I loaded before. I'm calling a template, giving it some parameters and some values, and it formats that information usefully for me. But if you look at the actual template, you notice that it's a little bit different. And so it has these identifiers that describe the actual properties of an event. An event has a name, a date, a location, and an organizer. And the fact that I add this little bit of extra information to the template is all that is needed for the wiki to become a lot smarter. And what a lot smarter means is that all of a sudden, if I wanted to make a list of events, like this list of conferences, I can do this by means of an inline query. So this is an automatic list that is updated whenever a new conference is added, and it just displays that event information on the page. So that's pretty cool. Wikipedia doesn't have that. So if you go to Wikipedia and you go to any of the many, many lists, for example, the list of countries by GDP, those lists are actually just plain text, and they're manually maintained either by human beings or by little scripts called bots, which make updates to them every once in a while, which is a pretty freaking painful process. So Semantic Media Wiki is pretty cool. So why are we not running it on Wikipedia? Well, there are a number of reasons we're not running it. One of them is it hasn't really been designed for the scale of Wikipedia. So it's been designed typically for smaller sites that have structured data needs. It runs very well when you're dealing with a few thousand pages. Wikipedia has 20 million pages, and it also has a ton of traffic, and it also has a very large and very intelligent community that would try to hammer that database and try to ask it questions and it just wouldn't scale. It hasn't been designed to scale. But the other thing, it doesn't actually do what we need it to do. So while it's very cool that I can make the wiki smarter, what I would really like to do is to make all wikis smarter. So there's a new effort, and that effort is actually not an effort by the Wikimedia Foundation. I'm the VP of Engineering of the Wikimedia Foundation, and the Wikimedia Foundation has a lot of engineering efforts, but Wikidata is not one of them. Wikidata is an effort that has been undertaken by Wikimedia Germany. Wikimedia Germany is a Wikimedia chapter, sort of like Wikimedia India, but in Germany. And they have started a new engineering project. And basically, the folks at the WikiConference said, hey, Eric, can you give us an update on that? And I said, well, yes, I can give you an update on that, but keep in mind, I'm not the person running this project, but I know what it's about. So Wikimedia Germany and I have been talking about this for a while, and basically they had been saying, why can't we just run Semantic MediaWiki? And so we had these conversations around what it would take to support structured data well in Wikipedia. And so the argument that I made, and that Denny, who is the architect of the Wikidata project, agreed with, is that the fundamental problem we need to solve is not just how to structure data in a wiki, but how to make structured data reusable for all wikis. In the context of multimedia, images, sound, videos, etc., we've very successfully done that with a project called Wikimedia Commons. When you upload an image file to Wikimedia Commons, and you're in Hindi Wikipedia, or Russian Wikipedia, or German Wikipedia, or French Wiktionary, or even a non-Wikimedia project, all you have to do is type the name of that image, and it'll become magically available to you. That's pretty cool. Wouldn't it be pretty neat if we could do the same with data? So what kinds of data? Well, if we think about this type of data, so this is a selection of screenshots from Wikipedia of info boxes. So these are just the 3 info boxes about Sweden from the 3 articles about Sweden in 3 different languages, but of course there are articles about Sweden in something like 200 languages. And all of these info boxes share data. Each of them, Arabic, German, English, has the same elements of data in it. Population, GDP, official currency, name of the current prime minister, etc., etc., etc. Now, even with Semantic MediaWiki, if I were to create an article about Sweden, let's say, for the sake of argument, that Telugu Wikipedia didn't have an article about Sweden. Of course, I'm assuming that it actually does, but let's assume it didn't. So you're creating a new article about Sweden. What are you going to do? Are you going to manually create a copy of the info box country template, localize it, copy and paste all the population data and every other bit of data from the English Wikipedia because that's the authoritative one? Why should it be that way? Why should we maintain 200 copies of the same data that have to be independently maintained, updated, kept up to date, fixed when something is broken? But that's what we're currently doing. All of these infobox templates have to be corrected when there is a broken number somewhere, when a source is inaccurate, when there's any issue with this data whatsoever. We have to go into 200 different language versions of this data and manually update them. That's insane. So what we really should be aiming for is a mechanism that allows us to centralize that. And that's what the new Wikidata project is about. So what Wikimedia Germany is trying to do is they're trying to create a Wikidata Commons, so to speak, a central repository for data in Wikimedia projects. And the way the project is going to start is by focusing on one of the more straightforward use cases of data in our projects. And that particular use case is interlanguage links. Who here knows what interlanguage links are? Okay, so very briefly. If I'm creating an article about this, then I need to tell Wikipedia where to find the other language versions of that article. So the way that is currently done in Wikipedia is by putting links in this format into the edit box. So I type FR, cheval, English horse, German Pferd, and whatever other languages I want to add. And the result of that is that in the left-hand navigation, you see these links to the article in other languages. So I'm sure you've seen those. That's where they come from. And right now, the weird thing about the way these links are being maintained is that there are actually as many copies of this set of links as there are versions of this article. So if I have the same article in English, German, and French, then each English and French will have this set of links on the article. So you have an unmaintainable system because you create all these copies of links. It's a very stupidly architected design. It's horrible. And so the way it is actually being maintained is that people write these bots, automated scripts that go in and say, whoa, someone added a new language link to the English Wikipedia. Let's make sure that the Swahili Wikipedia gets an update, and et cetera, et cetera, et cetera. So you run these very complex automated scripts all the time to make sure that this link database is kept up to date. But again, really, you should only have one link database. Ideally, what you would like to do is to point to a page and to just have one link, whatever it's going to be called, that pulls in all links. And that one link would have to be present in all the different languages. And that's the first project that Wikidata is going to tackle, is to try to build a central repository of interlanguage links. The second phase of the project is going to be about info boxes. So these nice little tables, like the ones about Sweden, to centralize the management and maintenance of those tables. So the idea here is that you have one wiki, one place on the web where you can go and say, I would like to update the population of Sweden. And every language Wikipedia that has chosen to pull in that information gets the updated version. So just as with Wikimedia Commons, when we upload pictures, they are available everywhere. With this project, when you add data, it would be available everywhere. Now, of course, data has to be localized. But a lot of that localization can either be done automatically or by means of fairly straightforward translation of one label to another. The word population has to be translated to Bevölkerung in German. So you have to have a label translation system. Then you have unit conversion. You might have meters in one project and feet in another. So you have to have the ability to flexibly convert units. Semantic MediaWiki has demonstrated that that's possible. Semantic MediaWiki does automatic unit conversion. And there are first prototypes that have been built that do label translation. So it's very much possible to do those things, but it's a step harder than just the interlanguage link repository, which is fairly straightforward. That's why it's phase 2. And phase 3 of the Wikidata project is going to be to manage lists. And the reason that is phase 3 is that here we're really talking about querying the database. We're talking about searches. So where right now, if you do the list of countries by population, you're talking about a page that's manually maintained. Again, what you'd ideally like to have is a query that says display countries by population, similar to the DBpedia queries we've just seen, as well as similar other systems for querying data. But then you're really going to start hitting the scalability challenges. Because with any kind of flexible inline querying system, you're going to run into problems when people write queries that run too long. You have to have very clear runtime parameters, how those queries can be run, how the data that results from a query, the query set is going to be updated and when, expiry of queries, et cetera, et cetera. So it gets even one notch more complicated. So that's the sequence that the project is going to undertake. They've just started the actual project work, so they are still hiring the team. If you go to wikimedia.de, and then you can find the Wikidata job openings that they have listed there if you're interested. I don't know if they take people from outside Germany as applicants, but they're currently in the middle of the hiring process for the project. So that's the overview of the new Wikidata project. It basically takes some of these elements and ideas from projects like DBpedia and Semantic MediaWiki and tries to take the best ones of those ideas and build a simple, straightforward application that serves the Wikimedia projects, as well as other potential reusers of that data from them. So thank you very much. I'm going to take questions now if there are any. You have had your hand up for quite a while. Please wait for the microphone.
Hello. You talked about the phase 2 of the project where you are going to be translating the labels and the units conversion. What about the actual data values also? So capital of India will be Delhi, but you have to actually translate it into that language. You can't say Delhi, right? You'll have to do the equivalent in those different languages. The value of the data.
So I think there will be a very interesting discussions about how to manage potential conflict in different languages, potential conflict in the meaning of data in different languages. Now, what we have to keep in mind is that Wikidata Commons, just like any other wiki, will have talk pages. So when there is a disagreement about what data should be shown and where, people will try to seek consensus. So hopefully they can agree. If not, what will probably happen is that people will choose subsets of data that are relevant to their specific language version. So you might say, I want only this particular variant, or I want only this particular field of the data set. If it makes sense to maintain multiple copies or multiple variants, or potentially even language conditioned values, which would get a fair amount hairier, then I'm sure that we would find ways to implement that.
I have two questions. One is about how are citations maintained in that common database, and two is how would you handle search on the language-specific, semantic search on the language-specific Wikimedias?
So the first question around citations. Wikidata, as it's currently conceptualized, does not try to build a citations database, and I applaud them for that. Oh, the source, yes. In fact, that is one of the design decisions that they made to support sources for each element of data. So if you're, for example, adding population, each field is intended to have a source annotation. So that's definitely supported. Can you be more specific? Right. So the question is, would you allow a search template that runs some kind of query to be constructed for a language specifically? And I think the answer has to be yes, because at the end of the day, the use case that we're trying to answer for is a lot of these manually maintained lists and various other currently manually maintained pages in the wiki. And those are very language-specific formats, very language-specific selections of data. So you should be able to say in Hindi Wikipedia, I want to have this particular list of data with these parameters. In English Wikipedia, I want to have this particular list with these parameters. Does that make sense?
On the Commons, even file search, the indexing takes about 24 hours before you can actually find files that have been uploaded today. So here it would again need to be indexed in.
Right. So this goes really to the heart of the architecture of the project and how the data would be stored in the first place. So when you're talking about indexing, you're sort of assuming that you're storing data as text to begin with, and then you're running some kind of indexer. But what these guys are trying to do is to store the data in an appropriate structured form immediately, so that there is no post-storage indexing cost. That storage could occur by means of a NoSQL database, like a MongoDB type database, by means of a key value store like Apache Cassandra. Like there are a number of new projects, open source projects for the most part, that are dealing with the storage and maintenance of big data. And when you're dealing with big data, you have to have highly efficient data stores with highly efficient search. Usually that highly efficient search is achieved by denormalizing data. So where in a traditional relational database, you really optimize for a specific structure in a denormalized NoSQL database, you might say, well, these are the 10 different kinds of things that people might possibly want to know, so we'll just store all of them, even if it means we'll store 10 times as much data, but it means that we have that data readily available and searchable if we need it. So you sacrifice often in those kinds of architectures efficiency for speed. So that's probably the direction that it's going to go. Denny has said that he wants to very seriously look at MongoDB as a potential data store. So that makes a lot of sense to me. If you look at a template, it already looks an awful lot like JSON to me. So it wouldn't be that strange to serialize it into something like a document or into a database.
I'm not sure how coherent this question is, but are properties or for example, Infobox properties, are they sort of globally addressable Wikipedia article name, Infobox title, property name, and presumably, at the granularity of the individual property?
So the most effort that has happened so far in terms of global addressability is what you have seen just now in the previous presentation with DBpedia. So that's really been an effort to provide global URIs for individual data elements, but also, not only that, they've also gone through a lot of effort in DBpedia to map properties in templates against vocabularies like Dublin Core to say this is what this thing means in another metadata vocabulary. None of this data exists in the context of Wikipedia itself. It only exists in third-party extractions like DBpedia. And in the context of something like Wikidata, we'll probably try to avoid at least as much duplication across languages as possible. So our goal here is to achieve global addressability in part by reducing duplication and having one copy of the data to begin with. One open question, which I've discussed with them a fair bit and which I don't think they've answered yet, is to what extent they want to map against other metadata standards. That's still to be decided.
And this is only tangentially related. I'm just curious about what is the current Wikipedia diff format, the internal between revisions? Not related to anything else you said.
Sure, completely unrelated. Diffs are computed on the fly using a, I think, C++ library called WikiDiff, which actually ships with MediaWiki, but you don't have to use it if you don't want to. Basically, it's just computing them when you pull them up. So if you compare revision A versus revision B, at that moment it runs the diff engine and says, here's what's changed between those two revisions.
I think in the interest of time, we can take more questions offline. We'll be going for a break now. We'll be back here at the same place at 4 for the State of Wiki session. Thank you, Eric.
Thank you, guys.